Yeah, very.
So I don't know what happened there, but we got banged. So where's this concave down? Did we already? Well, you guys figured that out while I was messing around. So what did you decide?
0 to 2.
F is concave down from 0 to 2. And why, Emmy? Was F concave down there?
Because F prime is decreasing.
Since F prime is decreasing. Good.
And then also then 3 to 4.
Oh. Also from 3 to 4. So while I was screwing around with the computer, you guys figured out the connection here that, I now know the points of inflection. F has points of inflection. At where? X equals 0 and 2 and 3. Because that's where F is going to switch concavity, right? How do I know the second derivative changes sign based off of not deducing the concavity thing? How can I just look at this graph and know that the second derivative changes sign? Well, the second derivative is positive here, then negative. So right there. The second derivative is negative, then positive. Right there. The second derivative is positive, then negative. Right there. So when F prime has a what? F has a point of inflection.
The max or min.
A local max or a local min. Right. Okay, so when F prime has a local max or a local min, F has a point of inflection. Okay. It's really weird in the news lately. I'm trying not to watch the news because it's so depressing, but in the news lately, you keep hearing these people saying, when they're talking about the virus, like we're reaching a point of inflection, which I don't think they're always using that term correctly. Because what a point of inflection really is, it's when your rate of change is at its maximum or its minimum. It's when your rate is either starting to slow down or speed up. Sometimes I think they're using that term correctly, but other times I don't think they are. There's actually all kinds of, interesting math that we could study with this virus. We could talk a lot about calculus with this virus data and like these graphs that you're seeing on TV all the time, but I decided I don't want to talk about it. It makes me anxious and depressed. So, but it's just frustrating when people are using math terms incorrectly. Is there anything else we can say about F there? Oh, we got 2 viewers.
Ooh.
We got 2 viewers right now. I don't know who they are. Maybe they could identify themselves in the chat. Is there anything else you can say about F there? And Megan, if one of those people is you, you said in your text that you were confused about 4.8. At the beginning of this, we did some problems from 4.8, which you can watch. But 4.8 is not on your test tomorrow, so don't be stressing out too much about that. But with this graph, is there anything else we can say about F? I don't think so. Okay, now I'm gonna add one piece of information to this. Okay. What did I effectively just tell you? By putting that 2 there. Like, I effectively just said F prime of 0 is 2, right? Okay, now what if I tell you this? Suppose F of 0 is 6. Could you tell me the equation of the tangent line to f at x equals 0? What do you need in order to write that equation of a tangent line? What do you need to write the equation of any line?
The point of slope.
A point and a slope. Do you have those two pieces of information staring at you? Yes. The point is
2. Or is it? No.
we're writing an equation of a tangent line to f. So the point is 0, 6. What's the slope?
Or is it 4?
Where do you get -4,
I
kiddo?
don't know. I said
So the question or the thing I want you to do is write the equation of a tangent line to f at x equals 0. That's what I want you to do. In order to do that, you need a point and a slope. You have them now. I had to give you both of these pieces of information for you to do this. I had to tell you what f was at 0. I had to tell you the y value of f at 0. So I told you it was 6. I made it up. But you also had to know the value of the derivative at 0. And so I put that 2 on there. So you have the point and you have the slope. So the answer would be y minus 6 equals 2 times x minus 0. Right? Now, if I would have changed the x value, like if I would have used -2, 1, or 3, you could have just picked the y value. I mean, the derivative is 0 there. You could have inferred that from the graph. But I had to give you a y value of a derivative in order for you to answer this question.
wait, what's the slope?
What's the slope?
Slope
The slope is 2 because that's the value of the derivative.
Oh, okay.
Remember, the slope of a tangent line to a function is the value of the derivative.
Okay.
I mean, what's the point of the tangent line? Like, what is that? You know, they're doing it right now. You see it all the time. Like, it's happening right now in front of you. It's before your eyes. At x equals 0, this function is changing at a rate of 2. Okay, and at x equals 0, this function is 6. Right now, we have 6 people infected, and it's changing at a rate of 2 per day. So we're going to predict. We're going to use this line right here. We're going to use this tangent line approximation to predict how many people are we going to have sick on day 20. We're predicting using that rate of change right now. That's what the tangent line is really doing. I mean, that's what the point of it is. It's like, okay, this is where you are right now. At 0, we're at 6, and we're changing at a rate of 2. Use that to say, okay, how much are you going to have on day 20, right? That's what the tangent line is. I mean, that's living out in front of us right now as we speak. But here's the deal: is this graph right here tells you how fast we're changing all the time. So if you want to, you can mix that up. You can say, well, if I knew what f was at 1 and I knew the derivative value, I could make a prediction there. I could think about how much will we have. I mean, use a new derivative and make a new prediction. You follow me there? So like finding the equation of a tangent line, it's all about basically. I mean, we say that all the time. Calculus at its guts is point slope. So where are you right now? Right now, in this case, is x equals 0. Where are you? Well, we're at 6. How fast are you changing? Well, according to that graph, we're changing at 2. So there we go. No way. We have 4 people online now? It's growing exponentially. So, like, I mean, that's a derivative problem. Like, right now we're at 4. And we're growing at a rate of 3 per hour. Right? it's just so it's so unfortunate that like when you guys learned lines, like equations of lines, you didn't learn that in a context of like linear growth and like what you didn't really learn that in a context of point slope. You learned that in a context of a bunch of symbol manipulation. Like, which is sad, because if you would have learned that in the context of point slope, like this is where you are now, this is how fast it's changing, like it would have made so much more sense to you.
Yeah, because now that makes more sense.
Now what makes
The point, so it makes more sense than it does at the beginning of the year, but it just confuses me because it's never what we did.
What do you mean?
We always did it in y equals mx plus b.
Right, which that's point slope too,
Yeah.
except the point is the y-intercept.
Yeah.
Like, and in fact, that's what this one would end up being.
Which one?
But if we just solve
Yeah, I mean, if I distributed this would end up being y equals mx plus b because the point that I was using was x equals 0.
Oh, but it's not like that on all of them, right?
No,
It just happens to be that one.
right, because I made this up as we were standing here, and I wanted to use a value. I mean, realistically, I wanted to use, when I was making this up, like what went through my head was, I was either going to make up one here or one here, and I just chose the first one. But like, what would be the, like, if I said, what's the equation of the tangent line at, say, x equals 3? What's the equation of the tangent to f at x equals 3? What do you need to know? You need to know a point and a slope. Of those two pieces of information, what do you have right now from that graph? The slope. And what is it?
0.
It's 0. So what if I told you, what if I told you f of 3 is 10? What if I just told you that? Okay? What would the equation of the tangent line be?
It would end up being like a constant, right?
So what would it be?
10.
Y equals 10, right? Because you would just do point slope again, and you say y minus 10 equals 0 times x minus 3. But now, don't just think, oh, I got that answer. Like, contextualize that. Like, what does that mean if we think back to the context? Okay, well, at x equals 3, we're at 10. We're not changing. So the tangent line says, if we're not changing, we're going to be for 10 forever. Like, does that make sense?
Mm-hmm.
Now, but we know that's not true because we're just not changing at 3. Just as soon as we move past 3, we start changing again. Okay? Nobody identified themselves in the chat. I mean, these could be like somebody in Australia just watching this. Yeah.
So on the test, it's going to be like, when we find the equation, is it going to be from a graph, or is it going to be like...
You should be able to find me an equation of a tangent line just about every possible way that's possible. I mean, because and what you just have to, the conversation that you have to have with yourself is, if I ask you to find the equation of a tangent line to a function, you have to say, I need a point and a slope. The point is coming from the y value on the function.
The point is from the original function, not
Correct.
the derivative.
Correct. Because if I were using the point on the derivative,
That's just the slope.
that's the slope. And that's the other piece of the information that you need. Now, I could be a real jerk and ask you to write the equation of a tangent line to f prime. Like, Like I could ask you to say, find the equation of a tangent line to f prime. Then you would have to know the value of f double prime. It would be the same problem, just one level down. But that would be jerky to do because then you, I mean, like I'm really testing whether or not you're paying attention. I don't know that that would be something I would do to you on a test. That might be something I would do in class. Like we would, like you guys all sitting in front of me, and I'd say, okay, tell me, and I would set you up to fail, like so that you would make that connection. Like, oh, this process is the same, but we're just moving one level down or up, depending on your perspectives. But I wouldn't do that on a test. Like that would be not nice. But yeah, you have to just have that conversation with yourself. Every time you're asked to find the equation of a tangent line, you have to say, I need a point and a slope. And eventually, these tangent lines are going to have some serious context to them. Like when we start talking about integration, and then we'll start solving differential equations, and it'll have serious context. But you use that idea of a tangent line all the time. Like I said, it's happening literally right before your eyes right now. You see it every day. Oh, 60 more cases today. Or, well, not 60. How about 6,000 more cases today? So 6,000 cases per day. Oh, I'm going to predict now that tomorrow we're going to have this many more because we had 6,000 today. Which that's pretty easy. Since it's per day, it'd be 6,000 more. But yeah, it's you're seeing that idea of point slope play out in front of you all the time. You do it when you're in a car on a long trip. You think about that. Have you ever been on a long trip with your parents and you're like, well, it's 100 miles to get there. How fast are we going? And you look how fast you're doing a point slope problem when you do that. Oh, we're going 60 miles an hour. So it takes, how long is it going to take me to get there? And it's 500 miles. You're doing a point slope problem. You're assuming that you're going to go 60 miles an hour the entire trip. What else? No. Could you do this algebraically? What I just this part right here. Could you do it algebraically if instead of me giving you a graph of f prime, I gave you an equation for f? Anna's looking at me like I have two heads. If I just gave you an equation for f of x equals blah, 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 blah. Tell me where f is increasing, decreasing, concave up, concave down, and points of inflection. Could you do that algebraically? You have to do the same analysis that you just did right here.
You just make a chart.
Yeah, you make charts. You find the derivative. In order to answer these questions, you need to have... In order to answer these questions, you need to have the derivative, right? Well, we had the derivative here in graph form. Well, what if I gave you the function in equation form? Well, then you find the derivative algebraically, And I told you, when you do this on the test tomorrow, it's going to be a polynomial, which is a very easy thing to find the derivative of. It's a very easy thing to set equal to 0. Right?
You said we had to know the quadratic formula.
Right, because think about that. If you take the derivative, right, and you get quadratic and you set it equal to 0, you're gonna have to know how to solve that. Do you know the quadratic formula?
Yeah, I think so.
Oh, okay. So that basically just told you. If I told you that you're going to have to know the quadratic formula, and I told you that the function that you're going to be dealing with is a polynomial, that basically just essentially identified what type of function I'm going to give you. Would you think about it? Well, maybe not. It narrowed it down pretty significantly. Do you see what I'm saying, Anna?
No. Wait, so we find the derivative and then we have to use a quadratic?
Okay, so if that happened, if you found the derivative and then you had to use the quadratic formula, what was the degree of the function you started with?
Third.
Very good. Because the quadratic formula deals with 2, right?
Yeah.
So if you start with a third, the derivative is going to be a quadratic, and then the second derivative is going to be a linear,
Yeah.
right? So that's one possibility where you have to know the quadratic formula. The other possibility would be that you start with like a fourth, the first derivative is a third, and then the second derivative is a quadratic. But the problem with that is, how do you solve that third degree equal to 0? Like, you don't have a cubic formula. There is one out there, but you don't know it. So if it was that, the third degree one would have to be something that you would be able to solve pretty easily. Like, so you really have 2 possibilities. It's either going to be a 4th degree or a 3rd degree polynomial. I will tell you it's probably going to be the easier of the 2.
It's gonna be my first in-person test.
Yeah.
In 8 months?
Yeah. And then I have another one too.
Really?
I have like 3 on the like right after. It's so
Well, I thought this was just a good way to end. You know, it's a good breaking point. Like my goal was to really get chapter 3 or chapter 4, the applications of derivatives, done before Thanksgiving. And I probably should end the live stream before I say this out loud. Like we skipped that one section, and we're going to skip that one section. I'm not going to lose sleep about that. So that when we come back, like after Thanksgiving, we will start the next phase of calculus, and that's integration. So we'll have 3 weeks before Christmas break, and then I think 2 weeks when we come back from Christmas break. So we'll have 5 weeks to sort of introduce integration, which I think we can reasonably get that done. And I'm not even sure, we might have, do we have 3 weeks after Thanksgiving, or after Christmas break? Or 2 weeks? Because we don't have semester exams week.
Wait, do we have it for this class though?
We're gonna have an exam for this class. I haven't figured out how that's gonna.
What if we're like online?
Don't even go there. Like I'm gonna.
Well, I guess then you have to.
You're gonna give me chest pains. Like, I don't know. I just don't know. If we're online after the semester or after break, Christmas break that is, I don't know what this semester exam is gonna look like.
Do other classes have exams? No.
No, we just have to have one because of Brett State.
Yeah, that makes sense.
And normally speaking, I either use their exam for Calc 1, or I write my own and send it to them, and then they tell me if it's okay. If we are online, I might use their exam if they did one that is easy to administer online.
Then we skip the section, so we're not gonna know.
I don't think they heard you. Yeah, so I don't know. That's stresses me.
It's a kind of long time from now.
Yeah, I mean, if you had asked me yesterday, I would have said that we probably would be online after Thanksgiving. But now I'm not so sure.
You don't think we're gonna be online?
Like right now, this is just my personal gut. My gut is that we're gonna forge ahead until Christmas. Because
I think
everyone.
more than likely, if it's gonna get bad, it's not gonna get bad until after Christmas, and we'll be out of school. Like with school related stuff. Yeah, people are gonna go home for Thanksgiving. We're gonna spread it around school, but it's not gonna start showing up until we get to
A couple-
Christmas break.
Yeah, a couple
Yeah,
weeks
so-
after is when,
I mean, everything's always about a 2-week behind, right? So, like, but I don't know. I mean, that's just my
because other schools have gone on.
right.
I think Centerville just went.
Yeah, Centerville switched 2 days ago.
Yeah.
They're switching online Monday.
Do you think we should do like hybrid after break instead of full time? So we're like more spread out. Because after break we're all.
No way. It's already like.
Man, we're up to 5 viewers right now.
And we're not even doing
I know,
that.
we're not even doing math. These people are just listening to our conversation. This is me personally. I don't know. I'm not going to say whether we should or shouldn't.
Yeah.
I don't think that the hybrid model that we have right now is sustainable for a long period of time. I think because it's really difficult for teachers. If you teach 6 classes, I mean, I'm very blessed, and because I'm a department chair, I only teach 4 periods during the day. And teachers that teach 6 classes have 18 groups of people they have to keep track of. They have to keep track of the kids sitting in front of them, the kids at home, who they're going to see tomorrow, and the kids that they're never going to see. And that's for every period they teach. Like, that is just not, like, it's not sustainable. I mean, teachers are pulling their hair out trying to do that. And it's difficult on kids, like, because they don't necessarily know. Even today, like, Megan's texting me, do we have a Zoom today? Like, it's difficult to keep track of when you're a kid of which classes I have to be at, which classes I don't have to be at. Like, so I just don't think the way we're doing that is sustainable. I think from the standpoint of like safety and sort of the best of both worlds kind of thing, the hybrid thing is nice. Like, it is nice, like having a group of kids in front of you. But I will be honest, like, because of the situation we're in, I've told people this, like, oh yeah, this is past 3 days where we've had kids in my class and I've gotten to teach math. Like, I really feel like it was only me at 75%. Like, I'm not able to do what I really would want to do because I've got these other people out there, and to try to manage that and get, it's just too hard. Because I need them engaged, and I can't get them engaged necessarily in the same way that I want the people in front of me engaged. It just doesn't transfer. So, like, I mean, perfect example is we're getting ready to start integration, right? Like I just told you that. We're getting ready to start integration. In a normal situation, like how we would develop that class, or develop that idea, would be a multi-day, like, experience where we are looking at a situation and really diving into it, looking at, this stuff that we were talking about before in a context where we introduce this idea of integration and what it really means before I just teach you how to do it. That's how it would normally happen. But for me to sort of package that and do that with you in front of me, kids at home who I'm going to see the next day, and then kids at home who I'm never going to see, like, there's no way to do it the way I would want to do it. That's why I'm saying it's like me at 75%. Like, so it's, but it is nice, like, having kids in the room. Like, having kids in the room is definitely better than me just staring at your screen and trying to understand what Ellie is saying. I mean, I don't know. I mean, it's just crazy. It's just crazy. Like, what are you guys thinking?
I think it's good if you can be here, but like missing one day, some of my teachers don't post anything. They don't have a live stream. So it's like, and I've heard from people that are doing fully online, like they're kind of like a little bit neglected by some of their teachers, which makes sense because there's a lot there's 3 groups. and
Right.
they have to focus
They're
on it.
spinning
Too
too many
much,
plates,
yeah, it's
right?
too
It's just, it's just not sustainable. Like, you know, there's a part of me that thought like if we were gonna be hybrid, if we could somehow work the schedule that we had with online and do that hybridly. Like if I just saw you twice a week for 75 minutes, that might be better than seeing you twice a week for 40 minutes. Because I think I could accomplish more if I saw you twice a week for 75 minutes, and I knew I was going to see you twice a week for 75 minutes. And then I could give you something to do on the day that I didn't see you, rather than trying to like keep you guys and the people, like everybody together. I don't know. I feel like it might work better. But how do you do that? I mean, we couldn't run the same schedule that we ran in the fall because that would have everybody in the building. Then it defeats the purpose of the hybrid. You know, the way we did in the fall, it's like, oh, we only have periods 1, 2, 3, and 4 on this day. But we can't have that because then everybody's in the building.
You just have to see what they decide to do.
Yeah. And there's just no right answer. That's,
But everything has like pros and cons.
yeah. There's just no right answer. It's just terrible. But hopefully it will end all in soon. Like I hope I never go through this in my career again.
I mean, this doesn't happen very often.
We have 5 viewers online. We don't, and they won't identify themselves in the chat. So I think there's people like in Europe somewhere watching.
No, you can't always chat. I can't chat.
This is on YouTube
On
Live.
YouTube Live, we're live.
I mean, I saw the chat, but I didn't.
Oh, we lost one.
I tried to chat, and it said that I had to have a YouTube channel.
Oh my gosh.
Maybe a YouTube channel.
Yeah, we lost 1 viewer.
I
So-
would not do that. I would not listen to this.
Well, we haven't been doing that.
Yeah, for like the past
Yeah.
15 minutes.
Are you like trying to pull a cosmetology stunt? Make them bigger from.
Oh yeah, I mean you guys might have other classes you're supposed to be in.
Yeah,
We
we
all-
actually do. We
Yeah.
all are in the same class that has a 2-hour Zoom today.
A 2-hour Zoom?
Yeah.
Wait.
What?
It's not required though.
It's not required, and none of it is during actual class. though.
Yeah.
It ends like right before class.
This is.
That's
Not
why
really.
this.
Like, should we go to the room?
No.